So, and I'm going to generate, and if you look into that, it's 1.2, 1.5, all the load combinations that we learned is actually here. Okay? So, one thing interesting is 1.2 dead load and 1.4 earthquake load. Why is there is no live load? Because, I mean, it will be statistically too much. So that's the core load combination we are going to use, and I'm going to save it. Now in steel, some of you were in my steel class and some of you took my steel class. Okay, you know that we had to go couple of things called steel, and then all the standard provisions and those. For concrete you do not have to do. Those are only for steel. Okay, standard provisions, seismic provisions, those are only for steel, not for concrete. So for concrete, we do not need to do anything. We'll just, once we run that analysis, we add the load combinations and then go back. Now, if you go to concrete design, okay, your gravity analysis is already done, your lateral analysis is done. Now all you need is design the beams and design the columns and design the shear also. Okay, so concrete beams. Okay, before I do that, I need to generate my load combinations. Okay, and it's the same load combinations will be generated. Okay, so I'm going to use that. Now I need to assign couple of criteria. Frame type, I'm not going to change. Seismic design criteria should be D. If I do the D, then it will actually take a long time, so I'm going to skip that part. Beam design, this is the code. That means for longitudinal bars we will use number 5 and above. Usually I go all the way up to number 10 bars, that's also the default. And for transverse, that means the stirrups, number 3 or number 4 bars. Okay. Clear spacing, again we are using the code specified numbers. Clear cover to the center of bars, if it is 1 layer 2.5 inch, if it is 2 layer 3.5 inch. Usually in my class I use 3 inch and 4 inch. Do you remember that? Okay, 3 inch and 4 inch. Lateral beams, for lateral beams we use a little bit more because it needs more cover. I'm just going to use it as it is, default. I'm just not going to do that. Change it. Bar selections, keep all the bars in the layer as same size. Usually that's what we prefer. If I'm using number 8 bars, then I'll use number 8 bars. Okay. I'm not going to mix it. If you want to mix it, that's fine. I'm not going to change anything. I will keep the design faults as it is. There are 2 special design checks that will be done. One is that torsional capacity based on the code, and include the deep beam. Deep beam means if the beam is short span, say 10 feet, but the depth of the beam is like 40 inch, then it becomes a deep beam, or 30 inch. Why? The reason is then bending is not a factor, but then problem is shear. Then the problem for that is if the shear is high, then the beam will go into shear deformation, not like bending deformation. You have to take care of that part. Okay. Usually, for this part we'll just ignore. So when we will run that, you'll see that a lot of beams will be in red color. Okay. Do you follow me? A lot of beams will be in red color. You need to go one by one and actually change them. Okay. I'm not going to do that. If it is a red color, I'll just leave it as it is. And for your submission, if it is a torsional problem, don't change it now. Do you follow me? If it is a red color for torsional problem, you can check what is the problem. If it is a red color. And if it says deep beam or torsional problem, don't worry. And not at this point. Because torsional problem, we have to do it by hand. Okay? We have to add special reinforcements at the middle of the beam, not at the top or not at the bottom. Plus, we need to change the stirrups into not 2 legs, but 4 legs or even more. Okay?
Why did you stick it up?
No, I don't want to, because I want to show you where you can expect torsional problems. Okay? Where is the deep beam problems? I don't want to give you the solution now. Okay? Okay, so that's one thing. Assign, okay, assign size. We already have sizes. Now usually in a normal case on a real project, we'll have like at least 30-40 sizes of beams. Okay, so I'm not going to use it. If it does not work, I'll just leave it as it is. Reinforcement layout. In terms to assign, you can click, or you don't need to click all of them because it's already showing in there. Deflection criteria, and I'm saying the default value of the deflection. You know that what is the default value? L over 240 for dead load plus live load, and L over 360 for live load only. That's the code specified. Okay, are you familiar with that? Okay, so in senior design you have learned that, right? Sure. Okay. Anyway, all of them combination is done. Design out. Let's see the designs. Done, and most of them are red. Don't worry about them. Why they are red? Okay, I can tell you why they are red. This one will have a torsional problem. This one will have a torsional problem. Well, this is a moment frame plus. It will have a torsional problem. And let's click on it. This is called view update. So click on one of them. Maybe this one. Let's see. What is the design warning? Torsional reinforcement required. That's why I wanted to show you why we can expect that. The other thing is, if you look into that for normal bending, it shows me all the reinforcement. Okay, that means we chose a 12 by 24 inch beam. For normal bending, on the top side, 2 by 8, 2 number 8s is fine. Middle, we are talking about top reinforcement. First interior support 1 is 2 number 8, support 2, 3 number 6, and it goes on if you want to get into the more. What about the bottom reinforcement? 2 number 7, sufficient. What about transverse reinforcement? That means stirrups. Number 3 size bar, span 1, number of legs 2, spacing 12 inch. Okay, so number 3 at 12 inch. Remember, I usually give that number 3 2 leg at 8 inch on centers. This is what the design will work. If you do that, number 3 at 12 inch, or you can place up to that length 9 number 3s. So that basically 12 inch. Here again number 3 at 12 inch. In the mid span, technically you do not need any stirrups because the shear is very low, and the concrete itself can take it. But since it's a program, we override that program. There is a requirement from the code is called S divided by 2. Okay, D divided by 2. Maximum spacing of the stirrups must not be less than D over 2. If your D is 20 inch, so D over 2 is